Welcome to Moving Straight Ahead, Problem 1.3. This screencast will go over setting up the graph, table, and writing equations so that you can answer the questions in order to analyze them. So our LEQ today is, how does the starting value impact the table, graph, and equation that represents the relationship? So in the previous problem, we worked with a group of students and they were coming up with a walkathon in order to raise money for a children's hospital. And now we are going to look at raising money. So in problem 1.2, the two variables that we looked at were the distance over time. And so as they walked for a certain amount of time, their distance increased. This tells you that the distance is the dependent variable, and you can go ahead and fill that in on your paper now, and that the time is the independent variable. So in that problem, as time passed, they walked further. Also, all three of those graphs for the three students all had the same starting value because at 0 seconds, they had walked 0 meters. So all of their starting values were 0, 0. In the relationships we're going to look at today, they don't all start at 0, 0. So each participant in the walkathon must find sponsors to give them money. So they try to decide how they want to get money from their sponsors. So they start looking at these questions about what kinds of things can affect how much money that's collected. Will the amount of money collected be the same for each walker? So they have a class discussion about that. You don't necessarily have to answer those questions. They're just important questions to consider. So the three students from before, remember we had Leanne and Gilberto and Alana. They each come up with their own pledge plan. So a pledge plan is how you're going to get money from someone who's going to donate money to the walkathon. So Leanne's idea is that she's just going to ask everybody for $10. So everybody she asks, she'll just ask them for $10, and no matter how far she walks, just a flat rate. Gilberto, wants to motivate himself to walk more, so he's going to collect $2 per kilometer. Alana hears Leanne's plan of getting the flat fee and Gilberto's plan of getting the $2 per kilometer and thinks to herself, well, I kind of want to have like a little bit of both. Like I want to have the guaranteed money, but I also want to be motivated to walk further. So she comes up with a plan that's a hybrid of the two, where she's going to get a flat donation of $5 at the beginning, and then for every kilometer she walks, she's going to collect an additional 50 cents per kilometer. So we're going to consider the three pledge plans, and we are going to use those as a way to be able to look for how the different starting values impact the table, the graph, and the equation, and also be continually looking at the constant rate of change in the graph, the table, and the equation, and just kind of get a firmer understanding of how that works. So the first thing we have to decide, though, is what are the variables in this situation if they're collecting money and walking. So we know that the two variables are the amount of money they collect, because they're collecting money, and then the number of kilometers they walked. So which one's independent and which one's dependent? The dependent variable is the amount of money, because the more Gilberto walks, the more Alana walks, the more money they will collect. So the money is going to increase as they walk more. So the amount of money they collect depends on how far they walk. So in comparison to yesterday or the other day whenever we did problem 1.2, distance was on the x-axis, but now, on the y-axis, now the distance will be on the x-axis because the distance is now the independent variable and the amount of money depends on the distance. So, based on the pledge plan, you're going to complete the table for each student. Remember, Leanne gets $10 no matter how far she walks. So if she walks 1 kilometer, she gets $10. If she walks 2 kilometers, she still gets $10. It's like working at the dollar store. You know, like no matter what you buy, it's all $1. Well, for Leanne, no matter what she does, she's only getting $10. So if she walks 6 kilometers, she gets That's right, $10. Gilberto does not get any money until he walks. So if he walks 1 kilometer, he gets $2, and then so on and so on. Alana gets $5 up front, and then an additional 50 cents for every kilometer she walks. So an additional 50 cents. So be thinking about that as you fill in the table. Make sure you fill it in with pencil, because after you watch this next slide, you might want to change some of your answers. So here are the results, by the way, of the table. I kind of thought it was going to come in gradually, but it didn't. There it is. All right, so Leanne's noticed that she has 10, 10, 10 all the way, because no matter how far she walks, and your stop, by the way, your table stopped at 6 kilometers. My table goes all the way to 10 kilometers, but it's okay. You don't need to change anything. So she even gets $10 even if she doesn't walk at all, because she got the money before she started walking. So no matter what she does, even if she stays home that day and doesn't even go to the walkathon, she still collected $10 for charity. Gilberto has to walk for charity, and notice that as the further he walks, how the amount of money he's collecting is increasing. It's getting more and more the more he walks. Here's the one you may have had wrong, so double check your table. See, Alana gets $5 up front, and then she gets an additional 50 cents for each kilometer. So what most students do is they have a tendency to, for 1 kilometer, they only write 50 cents. But you have to remember, she already has $5, and then she walks 1 kilometer, now she gets 50 cents more. So that's $5.50, and then she gets $6. So the more she walks, the more money she would collect for charity. Again, we want to remember, because we're about to make a graph, so we want to remember that the independent variable and the dependent variable, the independent variable is the distance. That is why the distance is on the left-hand side of the column, the left-hand column, because that's where the independent variable would go. And notice the distance is increasing by 1 kilometer. That's a good clue that it's the independent variable. The dependent variable here for all 3 people is the amount of money they're collecting. And we'll use A to represent the amount of money and D to represent the distance. Next, you're going to make a graph. It says here, make sure the money goes up to $24, but my suggestion that you only really have to graph 6 kilometers, so, anyway. So you're going to make a graph, and you need to label what goes on the x-axis. Remember, we just said that the distance walked is the independent variable, and then you need to label the y-axis and create a scale. So you need to make sure you're able to put in all the money that's in the table. So you probably don't want to go up by $1 because you won't have enough lines to get up to the number that you need in the table. So remember that. So once you've created the graph, we'll look at the next slide. So here's the graphs. Leanne's graph is in purple, and Gilberto's graph is in green, and Alana's graph is in, Gilberto's graph is in blue, and Alana's graph is in green. So Gilberto, notice he's got his line is this typical line that we're used to seeing, this right here that we did proportional graphs, and it's just increasing, and it's going up by $2 per kilometer. So $2, 1 more kilometer, $2 more, 1 more kilometer, $2 more. Alana's graph here doesn't start at 0, 0. Well, why not? Well, if you remember, she had $5 donation up front. So her line starts here at $5 on the y-axis. And then if you notice, her line isn't very steep. Finally, looking at Leanne's graph, hers is probably the most unique that we've seen so far. Hers is just a straight, flat line, because she's not getting any more money no matter how much she walks. She always collects the same amount of money. So her graph is flat. An equation for each person. And it's important to remember that the distance that they walked is the independent variable. So right now we had it's already set up for you that it has A equals A equals A equals. Well, remember, A is the amount of money they collect. And the amount of money they collect for most of them depends on how much they walk. So to write an equation, you need to think, what do you do to the distance in order to find the amount of money? So as you work through the table, what would you do to the number you have for the distance? What math could you do to them to get the amount of money collected? Now, I'm going to show you the answer for Leanne's now, so if you want to try it on your own first, you want to pause the video. But I'm going to do that one first. So when Leanne collects money, she only collects $10. So her equation is A equals 10, because it's always $10. Now you can try to write the equation for Gilberto and for Alana. So Gilberto collects $2 for every kilometer he walks. So that means he does, so $2 times the number of kilometers is going to give you the amount he collected. So his equation is A equals 2D. So yes, because $2 per kilometer is his unit rate. And so you multiply the unit rate by the independent variable. Alana's is a little more complicated because you multiply the amount of money she collects by the distance she walks by 50 cents. So she gets 50 cents per kilometer, but she also gets $5 up front. So to figure out how much money, for example, for like 7 kilometers, you would do 0.50 times 7 and then add $5. So her equation looks like this. It's a two-step equation. So now that we have made the table, made the graph, and written the equation, you need to fill in this graphic organizer. So the first column here is, what is the pattern of change observed between the two variables? So the first column is talking about the table. So as the distance increases by 1, the amount of money increases by, and then what happens. The next column is about the graph. So you should notice that each of these graphs, they might all be a straight line, but do they have any sort of differentiation between them? Like, is one steeper than the other? Maybe like Leanne's graph is kind of unique. Talk about how Leanne's graph looks. In the third column, you're going to try to find where is the constant rate of change in the equation. See if you can find it, and where is it located. The last column is the data proportional, yes or no? Is it a proportional relationship? And then how do you know? So there you go. Once you've completed this graphic organizer, we'll be sharing with each other in groups. Thanks.